In this lesson, we shall be taking a look at topic standard form. At the end of this class, you should be able to write numbers in standard form. So, what is standard form? It is what scientists use to write very large or small numbers instead of using lots of zeros. They write numbers in the power of 10. That is, a number in standard form, when it is written, has a multiplied by 10 raised to power n. That's an example of how a number is written in standard form, where a is a single digit between 1 and 10. In the close 1 but not 10, that is, between numbers 1 to 9. And n is an integer, that is the power. So let's move to writing numbers in standard form. To express a number in standard form, you must 1. First know where the decimal point is located, which is very, very important. Move the decimal point to the single digits, which could be numbers from 1, 2, 3 through to 9. The number of space moved represents the integer n. When the movement is from left to right, n is negative. That is, when you move your numbers from where the decimal point is located from left to right, then your integer n will be negative. And 5, when the movement is from right to left, that is where this decimal point is located, when you move from right to left, n is positive. Let's look at some following examples. Express the following numbers in standard form. 1. Given 0.006313. To express this in standard form, notice the first single digit number here, which is 6. Here, the decimal point moves 3 spaces from left to right. If you see where the decimal point is located, see the first 0 after the decimal point, the second 0 after the decimal point, the whole single digit number, the first one is 6. So starting from where the decimal point is, so the decimal shifts to the front of 6. That is your integer n, which represents the number of movements. It moves 3 times to the front of 6. That is, when I said in our first illustration that I explained, that when you are moving from left to right, it is always negative. And the number of space moved is 3. N here will be negative because we are moving from left to right. So our n here is -3, that is, it's moved 3 spaces from left to right. To express this number in data form, the answer in standard form gives us 6.313, that is your decimal point that has moved to the front of 6. It gives us 6.313 times 10 raised to power -3. I hope you get that. Let's solve another example. Example 2. Write 15000, that's 15,000 in standard form. The first number like this, where the decimal point is not shown, conventionally it is at the end of the number like a full stop, that is 15000. It is at the end of the third 0 that your decimal point is located. That is 15,000.0. So here the first single digit number is 1, and the decimal point moves 4 spaces from right to left. That is, from where our decimal point is, we move from right to left, and the number of movements to the front of 1 is 4. Let's see, 1, 2, 3, 4, 3, front of 1. And like I told you, when we are moving from right to left, our n integer is always positive. So here n is positive, which is number of movement is 4. So our 4 should be in positive number. So the number in standard form will give us 1.5 times 10 raised to power 4. If you convert this back to our normal figure, it will give us 15,000, because we have our movement back from left to right to be 4 space, which will give us 15,000.